I'm gonna show 20 Java exercises and one capstone project at the end in this video. Hello all, this is Murat Öksel. This video will help you if you are an absolute beginner or studying for Java interviews. Alright, let's do some practice. Here are my suggestions for you to get most out of this course. Code along actively. Don't just watch, open your IDE and try to solve problems first yourself. Pause and experiment. Try variations of the examples shown. Keep a learning journal. Note ideas for your own projects as you watch. Alright, let's start with first exercise. It is sales tax. A product costs something. Sales tax is 18%. I want you to calculate the final price. Round correctly to two decimals and compare double and big decimal usages. I use IntelliJ IDEA for this project. I created an empty project and I created 20 exercise folders for each exercise. Now you need to go to project, right click and mark directory as source root. By this way you can right click to folders and create Java files. Let's create sales task, Java class and a main method and define our variables and write our calculation for double variable. You see, we have 4 decimal numbers after that, but in many values, generally, there is no mean after 2 numbers. We can round many values to half up using this big decimal object. Set scale method is restricting the decimal numbers and giving the rounding method. We use half up in this case. Yes, final price using big decimal has only 2 decimals. Moving to the next exercise. In this one, we are given a string template and variables. We will replace variables with values and generate an invoice text as a result. This record type is a new Java feature. We will use it as a data transfer object. Generate invoice method will take user, charge, and due date as parameters. Let's prepare invoice template by copy pasting here. We will use this simple date format to convert date into a meaningful string. Now I am using replace method of string object to replace variables with values. Now in main method, I'm gonna call this generate invoice method with parameters I create. Let's run it, but it looks like I forgot to assign invoice generated to a variable and print it. Let's try again. Yes, the output looks fine. In the next exercise, I want you to ask user to input parameters and print out the result. We use scanner with system input stream to get inputs from command line in Java. I will read money value as double but convert it to big decimal afterward. I'm asking user to enter due date in a formatted way so I can parse it easily to date object. And finally, after getting all inputs, I am calling this generate invoice method and will print out the result. Right click and run it. After entering the bill charge, we got this unparsable error. That is because we forgot to read and ignore new line after next double. Next int, next double, and next long methods don't consume the new line. So we need to use next line to consume it and continue to parse input from user. Yes, now we have a good result. Let's see how it will look if we use print instead of println. Now it looks more natural, I think. Next one is number guessing game. Initialize a random number between 1 and 100. Ask user to input number to guess the initialized number. Inform user if it is greater or less than the target number. Keep asking user until the correct number is found. We can generate random numbers using this random object in Java. As this next integer method can generate 0 as well, we are adding 1 to get a number between 1 and 100. In order to keep asking user for input, we are using a while loop. Here we are informing user if the guess is correct or it is too high or too low. Okay, let's play the game. Yeah, it is funny, right? If you found this video helpful, please press like button and consider subscribing for more helpful content. Thank you. Next exercise is practicing arrays in Java. Please check requirements in this treasure hunt game and try to implement it yourself first. Basically, we will place treasure and trap in random places in a 3 by 3 array and try to find it. First, initialize a 3 by 3 array and initialize the values. Now determine the places to put treasure and trap with randomly generated indexes. I am using this do while structure to avoid to assign trap and treasure into same place. If they are same, we are generating a new random index for trap. Now implement the game logic in the while loop. If user enters exit, stop the game and return. Ask user to enter column and row indexes to check in cave. If that column and row encounters to the trap, that means game is over and user loses. If that is the place where treasure is placed, that means user won. If you want to extend this exercise, you can count the attempts and show to the user at the end of the game. Okay, let's play it a little bit. Yep, found it after a lot of trials. Next exercise is for practicing object-oriented programming. In this mining operators game, we need to define different types of miners. Each type of miner can earn different amounts of gold per hour. We will need to define 100 of them and we'll see how much gold each earned at the end of the day. Start with defining a miner interface. And a base miner abstract class for basic functionalities. Now start to define specific miners. First, it is placer miner and it will earn 2 gold per hour. Hard rock miner will earn 5 gold per hour. And finally, dredge miner will earn 10 gold per hour. And now implement the gaming logic. Initialize 100 miners randomly of different types. And then make them work for 8 hours. And finally, print how much each miner earned. Also, it would be helpful to see total gold earned. Let's run the game and inspect the outputs. Yeah, it looks fine. Next exercise is for functional interface and Lambda. Create a functional interface for simulating mathematical operations. Define functional interface integer op with apply method. Initialize add and max operations in main method for testing. Yes, it looks fine. Next exercise is for default and static methods in interface. Create loggable interface with default log and timestamp methods. You see, normally we don't put implementations in interfaces, but when we define a default method, we can put a default implementation. Now define a log service for implementing this interface. Let's test it in this main method. Okay, that looks working. Let's move on. Next exercise is for practicing comparable and comparator interfaces in Java. Create a task class that implements comparable, and that is why we need to implement compare to method. Implement compare to method with using integer compare and priority values of tasks. Now when we want to sort tasks by deadline, we will use this by deadline utility that implements comparator interface. Now let's see both of them in action in this main method. Define three tasks with different priorities and different deadlines. Let's try to sort them with usual collection sort method and with our by deadline utility. Yep, results make sense. Next exercise is for practicing collections in Java. Okay, this is a bit harder and take a back step and check the requirements. Basically, this exercise wants you to implement an in-memory LRU caching mechanism. Whenever a user logs in or does any action, add it into cache, and if cache is full, just evict the least recently used one. Before moving to solution, I want to show you the difference between hashmap and linked hashmap in Java. In hashmap, insertion order is not preserved and order is unpredictable, but in linked hashmap, by default, insertion order is preserved and there is an access order flag. When we give it as true, this instance preserves the access order. When we access an item, it moves to the end, and that is perfect for our LRU implementation. Let's move to the solution of our exercise. First, we need to define our data model. This is user entry. Now implement LRU user cache by extending linked hashmap. In this one, we will map usernames to user entry values. We need to override remove eldest entry method of this linked hashmap so it removes eldest entry when capacity is exceeded. Let's implement put user method to put user in cache in login or refresh cases. Okay, when a user wants to do any action, we want to get its rows and mark it as recently used. Let's implement one more method to print out current cache content. Because of the nature of our linked hash map, the order will be from least recent use to most recently used. Now let's implement the application logic. Print out the menu with options. Read choice from user and take action accordingly. We need this find rows method for just simulating DB fetch. So we want to determine if any evicted entry occurs and print out it. Once user selects the Do Action option, we need to get rows of the user, and that means it will be refreshed in cache. When user cannot be found in cache, ask user to log in first. When user found in cache, print out the rows. Once user chooses the Show Cache option, print out the current cache content in order from LRU to MRU. Once Exit option is chosen, stop the application. Okay, I think we are done. Let's review the methods and codes again. Run and play a little bit. You see we have an evicted log here. Root user is evicted when can user is logged in. Let's do an action with Steve and make it most recently used one. Yes. Now let's move on to the next exercise. This one is for practicing checked and unchecked exceptions in Java. Write a program that reads a file from disk. Handle the checked exception, IO exception, and see the difference between another unchecked exception, that is array index out of bound exception. You see, compiler wants us to handle these exceptions by giving a red compiler error. We can print out the stack trace like this. In part 2, let's cause an array index out of bound exception, that is an unchecked exception, by trying to access an invalid index. You see, compiler is happy it is not giving any error, but in runtime we see the exception. So let's handle that exception as well. Okay, when we handle the exceptions with try and catch blocks, program continues to execute from the next line. Now practice throw and throws. Write a method check age that throws an exception if age is less than 18. You see, when we throw a checked exception, compiler wants us to handle it. Let's try first with a value that will cause an exception. And then now with a valid value. Yeah, in both cases, we see program finished safely. Now let's practice custom exception. Create a custom exception class, insufficient balance exception. So if you want an unchecked exception, you can extend runtime exception. But in this case, let's make it a checked exception by extending exception class. Implement bank account class with withdraw method. If requested amount is greater than the balance, throw our custom exception. In other cases, just do balance reduction and print out withdraw successful. In order to test it, let's start with $100 in balance. First, withdraw a valid number. Secondly, try to withdraw a too much amount and cause an exception. Yes, in the output, we can see the first one is successful and in the second one, we got an exception. In the next exercise, we will practice try, catch, and finally blocks. Try to open a file and in the finally block, whether the file exists or not, print program finished closing resources message. Once file is read, print out the content of it. Add catch blocks for possible exceptions. And implement finally block that runs always whether exception happens or not. Okay, let's run it and try. Yes, we saw this program finished message in both cases. Now move on to the file handling exercises. In this one, we will list files in a directory with its properties. Is it a file or directory, size, last modified, etc. First, ask user to enter a folder path to list files in it. If that is not a valid directory, just inform the user. Otherwise, iterate over the files and print out all details. Let's run and try. Okay, it looks working. It printed out all the directories and files of the given pad. Next one is reading a CSV file. Prepare a CSV file with comma separated values, for example this one, and read it line by line and parse it into an account class. First, implement our account data model class. Read directly from accounts CSV file. Just make sure this file exists in the project folder. I will use this buffered reader to read file line by line. First line of the file will be the header line, so we need to ignore it. After reading a line, we need to split it by comma and then parse the values into account fields. Initialize an account instance from the fields. And finally, print accounts from the list. Let's prepare our accounts CSV file and run the application. Yes, it looks working fine. In the next exercise, we will practice writing into a file. In this exercise, we ask user to enter some notes and we will append it into the journal file. I will use this file writer class with append true flag so it will not overwrite the current content of the file. If user enters exit, just stop the application. Add a line separator into node because we want to write each node into a new line. Call the flush method to force write to file immediately. Okay, let's try it. Today I learned about file writer and node saved. Let's check the file. Yes, we see the node is appended to file. In the next a couple of exercises, we will practice streams and lambda. In this one, we will filter and print only even numbers of an integer list. Initialize an integer list. Use stream and filter method, and at the end, print out the result. Okay, that looks fine. In this exercise, we will use stream and map method to convert strings into uppercase versions. First, initialize a list of strings. Use stream map and to uppercase method reference, and at the end, print all of them. That looks fine, but we can also give Turkish locale to get correct uppercases in Turkish. Okay, that looks better. In this last exercise, we want to remove duplicates from a list using distinct and collect results into a list. Let's initialize a list of numbers. And use distinct and toList methods to get unique values. Okay, that looks working. Well done, my friend. Now it is time to practice all the learnings in a final capstone project. I want you to check all the requirements below and go implement it by yourself. After some trials, you can come here again and check the solution. I will not go through the solution line by line, but will just overview it. In this project, I want you to implement a command line Gradebook Manager that loads student data from disk, lets the user manage it, and saves it back. There should be validations for user input. You need to use private resources wherever possible. You will practice file reading and writing much. It is expected for a good level of logging of events as well. Okay, let's run it and see what it will look like. I'm adding some students with GPAs, listing the all students, saving the data into files, viewing the last 10 log lines. When we refresh the project, we can see the files generated. Now, I will overview the solution and source code, but I suggest you to implement it first by yourself. Then you can come here and check the source files. I hope this course helped you. If so, you can press like button and subscribe for more helpful content. Thank you for watching. See you on next video.